Lesson 8-6, Fractions and Perimeter. The main focus of this lesson is for you to find the perimeter of a rectangle, for you to discuss working with fractional dimensions, for you to solve a challenging perimeter problem, and to find unknown dimensions of rectangles. But first I want to go through the mental math and fluency of adding fractions. So 1/3 plus 1/3. Denominators are the same, so we add the numerators. 1 plus 1 is 2, so 2/3 is our answer. 30 hundredths plus 40 hundredths. Well, the denominator is already hundredths, so we add the top, 30 plus 40, and we have 70 hundredths. Notice how many of the mental math and fluency problems are based on adding, subtracting, multiplying. So it's really important that you keep practicing those math facts. So what we want to do is find the perimeter of this rectangle. Remember, the perimeter is the distance around a two-dimensional shape. So how would we find the perimeter of this? Well, I have this line, which would be exactly the same length as this line. So first of all, I would have 4a's plus 4a's. And I would add those together. Then I would add to that this line, which is 5a's, plus this line, which is 5a's. I'm hoping you're remembering that of what I told you, that you can often think of perimeter as plussing. We're plussing or adding the sides together to get our answer. So what is 4a's plus 4a's? Well, it's 8a's. And look at, I'm just bringing my sign down. What is 5a's plus 5a's? Well, it's 10a's. And notice I'm going to put my unknown here as P for perimeter. So what is 8a's plus 10a's? Well, my denominator stays the same. And 8 plus 10 is 18. So that is 18/8. So you could have started off right away and just added across 4 plus 4 plus 5 plus 5 and still got 18/8 instead of adding the two sides together to get an answer and then adding them together. Now I want you to open up your math journal to page 289. Let's walk through this problem together. Read it to yourself as I read it out loud. It says, Mrs. Wyman wants to install a metal fence around her rectangular backyard. The perimeter of the rectangular area she wants to enclose is 170 2/4 feet. 4 panels of fencing, each one is 7 3/4 feet wide, and 2 2/3 feet high were needed to complete a side. What are the dimensions of the sides of the rectangular area Mrs. Wyman wants to put a fence around? Okay, so we got to walk through this problem. First, you need to figure out what information is necessary. Well, the height of the panel is important. So the 7 3/4 is important. But the 2 2/3 feet high is really not. So if Mrs. Wyman needed 4 panels to complete one side, then one side of the rectangle must measure 31 feet. Why? Because it would take 7 3/4 4 times. Seven times 4 is 28. 4 times 3 is 12. My denominator again stays the same as 4. Well, 12 divided by 4 equals 3. So 28 plus 3 equals 31. So the width will be 31 feet. Now, if one side of the rectangle measures 31 feet, then the opposite side measures 31 feet. So the total length of two sides of the rectangle would equal 31 plus 31, which equals 62. So if the combined length of two sides is 62, but the total perimeter is 170 and 2/4 feet, then the sum of the other two sides must be 170 and 2/4 inches minus 62. So I need to trade or borrow the 7 becomes a 6, this becomes a 10. 2/4 minus nothing is 2/4. 10 minus 8, 2 is 8. I'm sorry, I got ahead of myself. 6 minus 6 is 0. And 1 minus nothing is 1. So I come up with 108 and 2/4. Okay, so if the sum of the two opposite sides' lengths we say is 108 and 2/4, then each side needs to measure half of this number, because the two sides total has to equal 108. So half of 108 is 54, and half of 2/4 is 1/4. So what's its length? Its length is 54 and 1/4 feet. So how many more fencing panels does she need to finish the remaining three sides? Well, if the width of the rectangle, again, is 54 1/4 feet, and I'm sorry, the length is that, and the width is 31 feet. So at least 4 panels will take to cover the 54 1/4. So, sorry for that interruption. So 4 panels were needed to cover 31 feet. So at least 4 panels will be needed to cover 54 1/4 feet. So let's figure this out. 54 1/4 minus 31 is going to equal 23 1/4. So after 4 panels are used, 23 1/4 feet still remain unfenced. Well, 7 3/4 plus 7 3/4 plus 7 3/4. Now I know I'm doing that 3 times, and this is going to be close because 7 plus 7 plus 7 equals 21. So I'm going to go ahead and start doing my adding now. So I have 21 feet. 3 plus 3 plus 3 is 9/4. Again, 9 divided by 4 is 2 with a remainder of 1. So my answer would be what I just found up here, 23 1/4. So knowing that 23 1/4 is how many feet these 3 panels will cover, I'll need 3 panels to cover the remaining distance. So 3 plus 4 is a total of 7 panels needed to cover the 54 1/4 feet. So 4 plus 7 will equal 18. So a total of 18 more panels are needed to fence the remaining 3 sides of the backyard. Next, I want you to go to your math journal, page 290. This is the assessment check-in, the ACI. So please, when you finish this page, bring it up to me so that I can check it off and check to make sure you understand what you're doing. It says use a formula to find the perimeter of each rectangle. Use fraction circles if needed. Show your work in the space provided. So one formula would be similar to what we did before. You could do, there's 2 sides of 2.5, so you could use the formula like this, 2.5 plus 2.5, and then find that answer, and then add it to 3.5 plus 3.5. That was one formula that we used to get your perimeter. Or, for number 2, a second formula could be just simply doing 3 2/4, sorry about that, plus 3 2/4, plus 3/4, plus 3/4. That also is another formula you can use to figure out perimeter. Pause the recording now, finish math journal page 290, and bring it up to me when you have it finished. After I've checked off your ACIs, I want you to go math journal page 291. These are math boxes. In math box 1, you're simply going to multiply. A good review skill for multiplying a whole number by a fraction. Math box 2 has you multiplying large numbers by simple numbers or 2-digit by 2-digit. Again, use any method you need to in order to complete those math boxes. Math box 3 says, Casey charges $11 per hour to babysit infants and $9 per hour for toddlers. She babysat infants for 22 hours. So remember, those are the numbers you're putting together. The 2 infant numbers. Okay, so she babysat infants for 22 hours. And she babysat toddlers for 18 hours. How much more does she need to earn to buy a $450 bike? So you need to figure out how much she's made so far, and then take that away from $450 to figure out your answer. Math box 4 says which costs less? 4 cups of fruit punch at 59 cents per cup. Okay, so you're using 4 with 59 cents, or 5 cups of orange juice at 49 cents per cup. So how much less? You should know what you're going to be doing there also. Plot the bracelet lengths in inches on the line plot below. What is the difference between the longest and the shortest lengths? And how many bracelets were sold that were less than 5 inches long? Stop the recording now, finish Math Journal page 291, then go up to the Math Journal answer key, correct it. If you get any wrong, please bring it back to me so I can clarify what you should have done instead. The last thing you're going to do for lesson 8.6 is Math Masters page 321. Please go to the file, get out Math Masters page 321, and complete this page for me. Bring it up to me before you go on to lesson 8.7. It says, perimeters and missing measures. Use a formula to find the perimeter of each rectangle. Show your work in the space provided. So I want to see your work here. Okay, and it's giving you the different lengths and widths. Next it says, for each rectangle, find the unknown side measure. So they give you 1, and then they give you what the perimeter will equal. You need to find the other one. And finally, do the multiplication practice at the bottom. So, pause the recording now. You are done with lesson 8.6. Be sure to bring up Math Masters page 321 to me when you're done.